Okay, so I was asked to do sort of a short refresher video on the distributive property with the binomials. So let's just look at something like 2x minus 4 times 3x plus 1. So one of the methods was to say everything in this set of parentheses has to get multiplied by everything in this set of parentheses. But the method that I learned when I was a kid, which helped me a lot, helped keep me organized, was called FOIL, which was first outside, inside. I'm just switching colors. So when I do this, you'll be able to see the difference. And I want to switch to one more color. Let's go last. Okay, so first means you multiply the two first terms. So the 2x gets multiplied by the 3x. So 2 times 3 is 6, and then x times x is x squared. Outside means you multiply the two terms that are on the outside. So 2x is the furthest on the outside, and plus 1 is the furthest on the outside. So 2x times 1 would be plus 2x. Next, you have inside, which is the two terms that are closest to each other. There's a minus 3, and there's a minus 4, and a times 3x. So 4 times 3 would be 12, but since there's one subtraction, it's minus 12x. And then the last one, which I have in purple, is the minus 4, the last term in the first set of parentheses, times the last term in the second set of parentheses. Minus 4 times 1 is minus 4. When you do this kind of problem, if you have this sort of look where they both start with an x and they both end with a constant, starts with an x, ends with a constant, you're always going to have the two middle terms that are like terms that can get combined. So here I would have 6x squared. I have a positive 2x with a minus 12x, more negatives than positives, and there are 10 more negatives than positives. And then you just tack that minus 4 onto the end, and this one would be done. Now, the difference is if you had one, like we do on much of the lab, with an extra term on the outside, that's actually the last thing you want to do. So this is still going to be the same first step, the first part of the process. So let's say I put a 3ut out at the front, and then I've got 8u minus 2t, and then I've got just a plain u plus 4t. So now I've got two letters that I need to worry about. If I multiply the two letters by each other and it's the same two letters, that's how I get squared. And if they're different, you just write them both. So I'm going to follow the same process that I did up here. And this 3ut, it's just going to hang around and wait for me. So first would be 8u times u, which would be 8u squared, because u times u, there's two of them. Outside, the 8u is on the outside, and the plus 4t is on the outside. A times 4 is 32. And then u multiplied by t, you just write both letters, ut. Then you've got inside, the two terms that are closest to each other on the inside of the problem. Minus 2t times u would be minus 2. Now you'll notice that there's a t and a u. I usually put them in alphabetical order. It also leaves the first one in the same order as the second one, both ut. And then last, the two terms that are last, is the minus 2t times the 4t. So minus times a plus. There's one negative sign, or you can say the signs are different. 2 times 4 is 8, so minus 8. T times t is t squared. And you've got all of this that's going to go in parentheses, and then you're going to remember to just stick that 3ut that you haven't used yet right back at the beginning. You're going to see if you can simplify, and you've got that same look where you've got matching variables. One's got a minus, one's got a plus, but they can simplify that middle term. So you're going to have 3ut times 8u squared, and then 32ut take away 2ut would just be 30ut, and then minus 8t squared. All I did in that step was combine the middle terms. And the last step is to distribute that 3ut to everything inside the parentheses. And here's where you get the extra exponents, the higher exponents. 3 times 8 is 24, so it's 24. U times u squared is u cubed, and there is a t. Next one, 3ut times plus 30ut. 3 times 30 is 90. They were both positive. U times u is u squared. T times t is t squared. And then the last one of the set, 3ut times the minus 8t. So 3 times 8 is 24. So I would have not plus, minus. 3 times 8 is 24. U, there's no U, so it's a single U. And then t times t squared is going to be t to the third. And nothing to combine at that point. That is actually your final answer, with just maybe some more mixed variable exponents. And I'm not going to do the last one out fully, but I do want to mention that if you have anything with, let's say, x plus 4 squared, anything with a squared, you have to write it out. It's x plus 4 times x plus 4, and you want to multiply the x plus 4 times x plus 4 first, the same way I did at the top with that FOIL, first, outside, inside, last. The 6x is just going to hang around and wait. X squared plus 4x plus 4x plus 16 until you get those plus 4x and plus 4x combined, and then you can distribute the 6x, which is the last step. I said I wasn't going to do the whole thing, but apparently I am. 6x times x squared is 6x cubed. 6x times 8x, 6 times 8 is 48. And x times x would be x squared. And 6 times 16, I don't know off the top of my head, and it's 96. So plus 96x. So there's 3 examples of the types of problems we have on the lab. Good luck.